Hey folks, welcome back to another video. Today we'll be looking at question 1379 and let's jump right in. The approach that we'll be using for the solution is a recursive method, and the way we'll be recursing is we will be looking at we'll be traversing both of the trees together, and as soon as we get the node that we actually want, we just return it. So let's jump right in, and then we can talk about the space and time complexity. Right, so the first thing you do is that we say that if our original is equal to the target, or if the original is equal to null, we would just return cloned, and then we will see in a second why that makes sense. And then the second thing you do is you say tree node, let's say a left, and then you get target copy, and you look at all of the left nodes, so original.left, cloned.left, and the target itself. And then you check if the left node is not equal to null, you would just return the clone. And let's see how that makes sense. So at this particular condition, we are checking if it is equal to the target, you're returning clone. So in that case, you're returning clone, and the left node that is being returned is not null. In that case, they are the same, and you're returning cloned. And if it is null, you would just follow the next steps, which is you would do that for the right node. Copy the target copy, and then you just look at all of the right nodes. Original.right, cloned.right, and the target. So let's just quickly see if that makes sense. And it compiles. The first case compiles. Okay, let's see what's wrong. So get left. Oh, you would not return clone, you return left. Alright, so let's quickly run this. That works, and in this case, okay, cool. Alright, so I hope that makes sense. Let's quickly go through this again. So looking at you're traversing both of the trees together, the original and the left, and as soon as you get something that's equal to the target, you're just returning clone, or if it is null, you would return null itself. Because since you're returning clone, if the original is equal to null, the clone will also be equal to null, and then you're checking, hey, if it is not null, that means we have found the target and you're returning it as is. Otherwise, you try to traverse the left at the right side of the tree. So the time complexity of this is O of n, which is the number of nodes in the tree, and space complexity would be of h, where h would be the height of the tree. And the reason why that is because since it's recursive, you would have to keep a track of all of the recursive calls that you have kept. So I hope that makes sense. If there are any questions that you want me to solve, please let me know in the comments below. Don't forget to like, share, and subscribe, and I'll see you all in the next video. Peace.